Hello, I'm Jessica Krapko, speech-language pathologist. Welcome to Praat Tutorials Episode 3. Today, we are going to reveal hidden layers in speech with filtering. Let's take a look at what that means. Filtering allows us to customize settings so that we can eliminate extraneous information and hone in on specific details of a sound signal. This is helpful because we know that some sounds have certain predictable characteristics, and we know what frequencies those characteristics become visible at. Knowing how to do this helps clarify acoustic feature visibility. As we know, Praat turns what we hear into something we can see. These filtering passes can help us distinguish between vowels and fricatives. It can help us enhance our perception of formants, and it makes teaching visually impactful. To do this, you want to load your sound file unless you've just recorded it. My cats are lurking nearby, so if you see their tails swishing in the screen, bear with me. As an obvious first step, you want to open Praat and either record the sound or open the WAV file that you have previously saved. Once you've recorded it or opened it, it should appear in your Praat objects list. Click on the sound you want to analyze so that it's highlighted. Then click View and Edit, which is right beside on the right. Now you're in the editing window and you want to confirm that you can see the waveform, which gives you amplitude information or volume, and the spectrogram, which is on the bottom and it gives us information about pitch. Making sure that both the spectrogram and the waveform are visible allows you to do more detailed analysis of the sound's properties. To make sure that these elements are showing, at the top ribbon, you can see where it says spectrogram, and you want to make sure that show spectrogram is ticked off with a check mark. To open filtering options, select the sound that you want to analyze, select filter, and then you can choose either pass or stop and decide which frequency bands to keep or remove from your sound. This helps you isolate specific acoustic features. Next, we want to choose our frequency band. This current setup will help you isolate and hear the middle frequency energy, and this is important for vowel formants. In the first window where it says from frequency hertz, you want to set that to 500. In the window where it says to frequency hertz, you want to put 2000. And for smoothing, the default is 100 hertz, and you can keep that. After you apply the filter in Praat, you can listen to the filtered sound. This filtered sound is going to be a new created object in your Praat object window, and it's going to be labeled sound filtered, so it's easy to identify. Click that sound filtered object and press play, and then you can experience the auditory effects of your filtering choices. So you can hear the difference between the source sound that contains all the frequencies versus the strip sound that you just simplified. This slide shows the difference between a filtered spectrogram with the vowel formants clearly isolated versus an unfiltered spectrogram, which is cluttered with more noise signal. Formants are the distinct dark bands that run horizontally across spectrograms. Being able to clearly see the formants makes it easier to identify the characteristics of different vowels. Conversely, if we want to analyze fricatives, we want to move our filter bracket from the lower frequencies up to the higher frequencies because fricative sounds have more of those whistly higher pitch sounds in them. So it makes sense that they would have more acoustic energy in the top frequency bands. So in this case, you want to set your filter parameters between 4000 and 8000 hertz. And this will let you hear the distinct characteristics of sounds such as the S or the sh, sh sound. So here we have all of the lower frequencies still visible, but after the pass, we now are focusing on those darker signals in the higher frequency range. And again, the difference between vowels and fricatives is vowels have more acoustic energy in the lower frequency range, where the formants are. So in the previous picture where the window was 4000 hertz to 8000 hertz, you can see that this one is from 0 to 5000 hertz. And then we've cut it again. So this is between 0 and about 2500 hertz. And this helps us effectively isolate key components of voicing, including the fundamental frequency and its harmonics or formants. And that reveals how vowels resonate in our vocal tract. In this next section, I'll show you how we can play with the parameters to change the outcomes. If you widen the filter band, more source sound is preserved. So you will hear a fuller representation of the audio, which captures various frequencies together. The narrower the band is, the more ghostly but precise it will sound. Using this technique isolates specific frequencies, which can result in clearer focus on particular acoustic features. You can also move this analysis band up or down the spectrum. This allows us flexibility in our analysis and listening experience. We can also combine different filters for layered acoustic analysis. This helps us capture multiple sound features simultaneously. Why do we need to be able to filter sounds? These tricks give us more clarity in phonetics. They help us isolate formant frequencies. In a later video, I hope to show you how the different dark horizontal bands in the spectrogram correlate with specific vowels. So for example, there are different bends or curves that can tell us what vowel it is and what consonant it's transitioning to. It can help us differentiate between phonation types. So you can actually see the difference between a voiced and a voiceless fricative. So voiceless would be an S sound, versus if you turn on your voice, you can get Z, zzz. It can help you more clearly visualize the turbulent noise, and it can make reading your spectrograms clearer and less cluttered. So the key takeaways from this presentation are that conducting filter passes isolates frequency band effectively. There's a pass filter, which retains sounds, versus a stop filter, which removes frequencies. These techniques enhance vowel and fricative clarity, and it has a better visual impact for teaching purposes. Although I've done a few videos that functionally demonstrate how to record acoustic samples for voice assessments as an example, in Praat episode 4, I'll go into more academic explanation of essential techniques to capture high quality sound for accurate acoustic analysis. As always, thank you for stopping by. For more information, check out my other Praat videos on this playlist. Or to see how I use this information clinically, you can check out my voice therapy playlist for more related nerdy speech science facts. Thanks so much. Have a great day.